Alright, let's do some 3D geometry questions today for Igcse math, of course. Now, the first question is a pyramid with a rectangular base, PQRS. The diagonals of the base meet at M, and V is up vertically above M, which means that there's a perpendicular, this M and V are basically going to have this 90-degree over here. Now, PQ is 8, QR is 6, VM is H, and the volume is 112. What we know is that the volume of a pyramid with base area A and height H is going to be volume is equal to 1 by 3 AH. So the volume we already know is 112 is equal to 1 by 3 into the area. The area of the base in this case is going to be the area of the rectangle PQRS, which is nothing but 8 into 6. So I'm going to write that as 8 into 6, and then you multiply that with the height. So to make h the subject of the formula, well, first thing we can do is just simplify this. So we get h is equal to 112 divided by 8 into 2, which is 16, and that is going to be 7. If you want to check that on a calculator, 112 divided by 16, poof, 7 centimeters. That's the height. So let's label that h. Now, calculate the length of VR. The way to approach this is basically to use this triangle over here. The base is MR and the height is VM. This is 90 degrees. Height we know is 7 centimeters, sorry. So I have to rewrite that. The height is, yeah, the height is 7 centimeters. Height is equal to 7 centimeters. Yeah. Now, how do we find out MR? MR is nothing but half of PR because M is the midpoint of the line PR. So we have to do is find PR. And how do you do that? Well, we can use Pythagoras for that. PR is, well, this is also perpendicular, right? Because this is a rectangle. So PQR, angle PQR is also 90 degrees. So you can use Pythagoras theorem. This is going to be PR squared is equal to 8 squared plus 6 squared, and so we get PR is equal to 48. Well, root of 8 squared is 64 plus 36, which is going to be plus minus 10, but obviously lengths are measured in positive values, so this is going to be 10 centimeters. So if PR is 10 centimeters, then MR is going to be 5 centimeters. So this is 5 centimeters over here. So what do you find out for VR? VR is going to be, again, Pythagoras again. So 7 squared plus 5 squared, root of that is going to be VR. So VR is equal to the root of 49 plus 25, right? So let's find out the value for that. That is going to be root of 74, which is 8.6. So that is the length of VR. Now next we have K, which is the midpoint of PS. So this is going to be K. And then we have L, which is the midpoint of QR. So this is going to be L. Because it's the midpoint, that means that this, if I were to join this line over here, this will pass through the point L. So I will just redraw it to pass it through L. And then erase the previous one. So it looks something like this. That is what the diagram is now going to look like with the points K and L involved. What we need to do is find out angle KVL, and the best way to do that is to use cosine rule in the triangle KVL. So I'm just going to use this as a triangle. This is K, this is L, this is V, right? What is the value of KL? Well, KL is going to be parallel to PQ, and the reason behind that is the line KL is nothing but PQ shifted 3 units in the same direction, 3 centimeters in the same direction. So because they're parallel, they're going to be equal in length as well because they're confined in the same region. So PQ is equal to KL in length, and PQ is 8 centimeters. So this is going to be 8 centimeters. Now the next thing we need to do is find out the length of VL and the length of VK. And what we know is that they're going to be the same length. How do we find out VL now? Yeah, so we know the height. Height is 7 centimeters. And we know what ML is. ML is going to be half of KL, which is going to be 4 centimeters. So with that, we use the triangle VML and VMK to basically use Pythagoras over here. So I'm just going to draw the triangle over here. This is V, this is M, this is L. This is 90 degrees. This is VM, which is nothing but the height is 7 centimeters, and ML we know is 4 centimeters. So what we need to do is use Pythagoras to find out VL, which is going to be the root of 7 squared is 49 plus 16. So the root of, so just write that as root 65. So this is going to be root 65 centimeters, and this is going to be root 65 centimeters. Now I'm going to erase some and just make some space over here. All right, now we have the units given to us, and what we need to do is use the use the cosine rule and find out this angle over here, angle KVL. So V is in the center. We need to find out the angle over here, which is going to be theta. So what is theta going to be? Theta is going to be cosine inverse of root 65 squared plus root 65 squared, yeah, minus 8 squared divided by 2 into root 65 into root 65. So I'm gonna simplify that a bit. So it's going to be cosine inverse of what? Root 65 squared is 65. Root 65 squared is 65. So 65 plus 65 minus 64 is the numerator. 65 minus 64 is 1. So it's going to be basically 66 over here. And this is going to be root 65 into root 65 is 65, because 65 squared basically. And 65 into 2 is going to be 130. So that is going to be the answer. Cosine inverse of 66 by 130. 66 by 130, which is going to be 59.5. So I'm going to write that as equal to 59.5 degrees. Okay, next question. A piece of metal in the shape of a cuboid, and we have some units given to us. We need to find the volume of the metal remaining after the cylinder has been removed. So first thing we need to do is find the volume of the metal in its entirety, and then basically remove or subtract the volume of the sphere. And we do that by simply finding the volume of the cuboid, which is going to be 18 into 12 into 12. So 18 into 12 into 12. And from that we subtract pi r square h, which is a volume of the cylinder. So pi into r is 4 squared, which is going to be 16, into h. H in this case is going to be 18, because that's the length of the cylinder across which we are multiplying the base area over here. So this is going to be the answer. We just simplify it, and this is going to be 18 into 12 into 12 is 12 squared, which is 144. So 2592. So 2592 minus 16 into 18 into pi, which is going to be 288 pi. And then we just simplify it. 2592 minus the answer which we got previously, which is 288 pi. And that answer is going to be 1687. So I'm just going to scratch that out. This is going to be simply 1687.22. What is the unit of volume? Centimeters cubed or milliliters. Next, write your answer in standard form. So standard form, it has to be something like this: 1.68722 times 10 to the power 3 centimeters cubed. So basically, when it comes to standard form, this part over here, which is before the decimal, has to be somewhere like it has to be between 0 and 10. This thing you can just forget. It can't be 0. It can be 0 actually, so it's going to be this, but it can't be 10. So it has to be 9 point something. Yeah. So that's going to be the answer for part 1 in standard form. Now next thing is find the total surface area of the metal remaining after the cylinder has been removed. So first thing we need to do is find out the area of this surface, there's a bottom surface, this surface in front, and this surface in the back. So the area of that is going to be 18 into 12 into 2 plus is going to be this. And then the next thing is this surface over here. This square over here is going to have an area which is 12 squared minus the area of the circle. So it's going to be 12 into 12 into the, subtract that, right? So we just go over here, subtraction instead. So it's going to be 12 into 12, which is 144, minus 4 squared is 16, so it's going to be pi r squared is going to be 16 pi. Yeah, and this is going to be times 2 because there's another surface with the same value over here. And then the last thing we need to subtract is the internal surface area over here, which is of the cuboid, of the cylinder, sorry. So we subtract what? We subtract pi r, 2 pi r into 18. So it's going to be 2 pi into the radius, which is 4, into the length, which is 18. So if I were to just explain the 2 pi r h formula that I used, it is going to be simply this. The cylinder inside is basically like this. This has a radius of 4 and this length we know is 18 centimeters. So basically the circumference of the circle on top over here is going to be 2 pi r, and the surface area basically of this curved surface over here is going to be the circumference into the height. So it's going to be 2 pi into the circumference, so that's the circumference 2 pi r into the height, which is 18 in this case. That's basically the derivation of the cylinder's surface area, the curved surface area. So basically we need to simplify this whole thing, and let's do that. So we have 18 into 12 into 12 is 144, and that is repeated twice, so that's going to be 5184. Then we add 12 into 12 is 144 into plus, then 144 minus 16 pi into 2, because there are two of them. This is 5371.469, and then you subtract 2 pi into 4 into 18. So minus 2 into 4 is 8, 8 into 18 into pi. Sorry, pi. It's going to be 4919. So the final answer is 4919.8 centimeters squared, because surface area is in centimeters squared. Now, the cylinder removed is melted and formed into 16 identical spheres. Calculate the volume of one sphere. So the total volume of the cylinder is pi into the radius square, which is 16, into the height, which is 18. And this is basically divided into 16 different spheres. So this cancels out to give us 18 pi, which is going to be 18 pi is equal to 56.55 centimeters cubed. The volume of a sphere is 4 by 3 pi r cubed, and we know that this is nothing but 18 pi from the previous question. So pi and pi cancels out, and r cubed is going to be 18 into 3 divided by 4. This we'll get as 9, so this is going to be 27 by 2, and then r is equal to the cube root of this, which is going to be 3 by cube root of 2, sorry, which is going to be what? Well, okay, let's just do cube root of 27 by 2, which is 3 root 6 by 2, 3.67. And radius is measured in centimeters, not centimeters squared, not centimeters cubed, so this is going to be the answer. Fine. Now this is the third question, and it looks very challenging, but it's actually easy. So let's proceed. The first question says that we need to show that AB is equal to 8.66 centimeters. So first off, let's just draw the triangle ABC. So this is what it's going to look like: A, B, and C. So what we know is that if I make a line over here, a point over here, which is the center, and then extend from there, yeah, this is nothing but the radius, this is the radius, this is the radius, and all of those circles are equal because they have the same radius. So this is going to be 5, this is going to be 5, this is going to be 5. Let's call this point M. That's basically the representation that we have. So what we can do is just make a circle, make another triangle over here, which is going to be M A B, and we know that AM is 5 and BM is 5 as well. So we need to find out AB. Now another thing that we know is that this entire T is 60 degrees, and over here, one second, yeah, angle AMB plus angle AMC plus angle BMC is going to add up to what? 360 degrees. Now 360 divided into 3 equal sections is going to be 120. So angle AMB is over here is going to be 120 degrees. So now we find we find length AB by simply using what we use cosine rule. So the formula for the cosine rule is going to be, let's erase this over here. Yeah, so if we were to write it, I'm going to change the color again. So AB squared is equal to something, but AB as a root is going to be 5 squared plus 5 squared minus 2 times 5 into 5 into cosine of 120. 120 with that, that's a 0. So let's put that in the calculator. Root of 5 squared is 25, 5 squared is 25, so 50 minus 2 times 25 is going to be 50. Into cosine of 120, which is going to be 10. So AB is okay. Well, let me write it again. Sorry. Now if you go up and look at this, it's going to be 2 times 25, which is minus 15, or minus 2 times 50. So it's going to be minus 15 to that, which is going to give us 5 root 3, which is 8.66. So sorry, that's my bad over there. This is going to be 8.66, and this is going to be 8.66, which is what we need to prove it as. Correct to 3 significant figures. Now calculate the area of the base of the radio. So this entire thing over here, we need to find the area. So let's get started. First thing I'm going to do is, we know the length of AB, AC, and BC. Right, so this is one thing, this is one thing, and this is one thing. We know those lengths are 8.66, and this over here is the radius. So this is going to be 5. This is going to be 8.66, right? So we can do is simply use that 5 into 8.66 into 3 to find the area of the rectangles AECD, BHCI, and FAGB. So 3 into 5 into 8.66 is going to be the area of this rectangle, and this rectangle. After this, we need to find the area of triangle ABC. So triangle ABC, we know the length, we know this length, we know this length, and we know this angle. So what we need to do is simply use sine rule. So plus sine of the angle is 60 into that AB is 8.66, and BC is also 8.66, and then you divide that by 2. That's the area of the triangle when only the side lengths and the angle between them is given to us. Now the last thing is the area, which is over here, this area FAE, GBH and ICD, and they are equal to each other as well. So all we need to do is work out this angle over here and use the sector area formula. So plus this we know is because it's an equilateral triangle. This is 60 degrees. This is 90 degrees. This is 90 degrees because they are rectangles, right? So because of that, all we need to do is subtract that from 360. So 360 minus 90 minus 90 is 360 minus 180, which is 180 degrees. Now 180 degrees minus 60 degrees is 120 degrees. So this angle over here is 120 degrees. Now 120 divided by 360 into pi r squared. Pi radius is 5 squared, which is 25. And guess what? We have 3 of them. So I'm just going to multiply this whole thing with 3 as well. So this is going to be the total calculation for finding this entire area over here. This entire area. So let's put that in the calculator. So 3 into 5 into 8.66. Yeah. And then to that we add sine 60. So sine 60 into 8.66 squared squared into 0.5. It's the same thing, right? Plus another bracket 120 divided by 360 is 1 by 3, so I'm just going to write that as 1 divided by 3 into 3, so that basically cancels out. So it's just 25 pi. So this area is 240.91, and the units are centimeters squared. Now next, the height of the radio is 12 centimeters, so we need to calculate the volume of this radio. So we just do the base area into the height. So it's going to be 240.91 into 12. So 2890.97 centimeters cubed. So that's the final answer. And that's it for today. Hope you understood the questions that I solved.